Hello everyone and welcome back to another video here on the Polaris School of Quantum. Today we are going to look into Pfeiffer Vacuum. If you've never heard about that company, then you should rather stay tuned for today's video because their machines are basically everywhere in the whole quantum system. And it's also going to be a shorter video, I think, than per usual, because I just want to point out the importance why they are basically everywhere and why their products are so important. And with that, let's hop right into their website. So here it says vacuum technology in research and development, which, to be honest, most of the quantum stuff still is more or less research and development. In the background, we also see some vacuum chambers here. As a company trusted by scientific institutions and universities worldwide, Pfeiffer Vacuum and Fab Solutions provides complete vacuum systems that support research in labs and large-scale scientific facilities worldwide. From material science to particle physics and space technologies, our solutions create stable, clean environments so you can focus on results, not set up. Powering research across disciplines, and then here we have whether you're developing the next generation of semiconductors, exploring quantum materials, or running high energy physics experiments. Different pressure levels address specific research needs. Rough to medium vacuum supports common lab processes such as glove box, schlenk lines, and drying. That's probably not extremely relevant, but it's a topic as well, but maybe not so super relevant for quantum. Then high to ultra high vacuum UHV is essential for surface science, plasma physics, and cryogenic research. And then the ultra high vacuum UHV enables precision in particle accelerators, surface analysis, and high energy physics. But vacuum was more than just selecting the right pump. The systems must also be properly connected, precisely measured, and continuously analyzed. From instrumentation and sensor integration to residual gas analysis and leak detection, Pfeiffer provides a complete vacuum solution that ensures your setup performs reliably and efficiently. And now quick zoom out. So how is that relevant? Where does it play a role? And I've seen those devices many times in my research time. That's also why I wanted to put them into this Hidden Quantum Champion series. And now let me quickly explain you why. So if you are, for example, working with any type of solid state qubit technology, be it superconductors, be it semiconductors as in, let's say, confined electrons, but basically everything that is on this chandelier type of setups, you basically need to cool those things down. And if you want to operate such a fridge, such a cryostat, then you will also need a vacuum pump, because usually you need to remove all the air from the system before you can actually start the cool down, because otherwise it will at some point start to condense and then freeze into your system. Plus also it is much more difficult for the system to cool down because there's no well insulation. So you will need this basically in all of those types of systems. Now, if you're looking into ion traps and neutral atoms, well, you also need a very strong vacuum, because you need to be able to separate those from all the air that is around. So there, the vacuum requirements are even harsher, even stronger than in those cryostat systems where maybe a high vacuum is already enough. Here you need like an ultra high vacuum. You don't want to have any particles basically that are roaming around in those chambers. So again, you need vacuum pumps for that. So basically, for most of the relevant quantum computing schemes as of today, maybe with the exception of all the photonic stuff, you basically need vacuum pumps for this to actually work. Now, even for the photonic, I would argue that vacuum pumps do play a role, because usually those things are going down into chips. You have maybe like laser kind of fabrication and so on. And for all of those chips today, you will need vacuum systems to work actually in the clean room lines, in the production steps, because they are usually prepared or produced with kind of surface state, surface technology, so surface deposition technologies, be it chemical vapor deposition, molecular beam epitaxy, be it evaporation of different metals. And whenever there is any type of surface treatment that basically goes down to the quantum level, you will always need to do this in a very clean environment, and that's usually when you need a vacuum. So again, you will need a vacuum pump. And that's also why in every clean room, you will always find vacuum pumps. These are ranging from, let's say, high vacuum all the way up to ultra high vacuum molecular pumps. Now, whenever you have something that needs to carry a vacuum, whenever you have something that needs to carry a gas, especially when it comes to these semiconductor manufacturing processes where some of the gases are just very expensive or very toxic and dangerous, you always want to make sure that everything that you are building there is actually leak tight. So you need a leakage detector that you can actually use to see if the system that you build is tight or if there's a leakage somewhere. So again, you will need a leakage detector system. That's also something that Pfeiffer is providing. Then on top of that, you also have mass spectrometers and other important components that you actually need to build those vacuum systems. And that's why basically their stuff is everywhere in almost every quantum lab. Maybe there are also competitors, right? Some quantum labs might also have stuff from other competitors. I think from my experience working in different labs and also seeing different labs throughout my research career, I can say that it's usually a very broad mix from different manufacturers, but I've seen Pfeiffer many, many times. Let's quickly take a look at the rest of this website here. So vacuum applications in R&D from big science to basic research. We see particle accelerator, space and laboratory vacuum. Since we are not aerospace or particle accelerator website here, I guess we are not going to look into this, but another one down here, and I mentioned that before, is cryogenics, right? So avoiding thermal loss and ensuring vacuum insulation stability are key to achieving reliable results in low temperature and superconductivity experiments. And if we are looking at the products, this is exactly what we see. So turbomolecular pumps play a very important role. You also have these scroll vacuum pumps that are, I think, usually oil-free, which is also very important in these types of environments. But you also have a normal rotor vacuum pump. You see these small setups here. I think we also had one of those in the lab. Very, very useful because they're usually a combination of a pre-pump and a molecular pump. So that's basically how you drive every molecular pump. There are also these ones here, which are water cooled. I think similar ones used to be, at least when I was working with those, in the Oxford Instruments, cryostats. And then there are also other ones like the leak detectors down here that are being used to find leakages in those systems, and even bigger pumps, which I think will be required to build these bigger cryostats that we need as the number of qubits on your chips are scaling up. So I think in general, it is a very fundamental piece of the quantum ecosystem, and I mean their sales into the quantum is scaling with basically all the mainstream technologies that are being scaled up, and where more of them are being built, if they are of course the supplier to those companies. So from my point of view, very much a hidden champion and a very important one. As always, let's quickly check out about the company at the very end. So Pfeiffer Vacuum and Fab Solutions, cutting edge vacuum solutions for exploring the frontiers of knowledge, pushing innovation beyond its limits, and advancing humanity through excellence in high and ultra high vacuum technology. Here we see there are actually two brands that are part of this group. So there's Pfeiffer and then there's Bush. Then on the group, I mean, there are the effects here: 2 billion euro turnover, 44 subsidiaries or country subsidiaries, 23 production sites, and 8,000 employees worldwide. 1890, a bright idea sparks it all. It began with the visionary mindset of a 23-year-old mechanic from Wetzlar in Germany. Actually, I've been driving through driving by this place in Wetzlar, and I think also in Aslar, multiple times. So it says Arthur Pfeiffer founded the company in his own hometown, initially producing gas lamps and remote igniters. As electric light emerged, he immediately understood that this technology was the future and that it had one major problem: the vacuum process of the time were far too slow to keep pace with demand. And then I guess that's the start into the whole company, and now it is basically all over the world supplying with these vacuum technologies. And I mean, since I'm dialing in from Switzerland, I guess I get the Swiss address here as well. Well, I mean, that's everything for today's video. As I said, it's a bit shorter than usual, but I think not less important than usual. If you wanna, let's say, learn more about companies that might not pop up super prominently on the radar when it comes to quantum technology, then make sure to stay tuned to this channel, subscribe to this channel to not miss out on the next video of a Hidden Quantum Champions. I'm looking forward to see you back very soon again. Until then, bye-bye.